formula sheet, it has these formulas on it. We went over the factorial symbol. We went over NPR. Now we're looking at NCR. It's n factorial over n minus r factorial. Now this is when it's a combination. They can also, instead of writing it as NCR, they can write it as brackets and then just have the two numbers. So they could write it as, if it was 10C3, they could write that as 10.3. And that means C. Okay, it can't be a P, it's a C. It even tells you on some formula sheets, so you really can't get it mixed up. Now, the thing about permutations is order matters, and the thing about combinations is order doesn't matter, right? So I was telling you that, for example, when I told you, I said pick 3 people to go on a trip out of this class, right? If you're just picking 3 people to go on the trip, and they just got to go on the trip or not, would order matter? Of those 3 people you picked, if you were picked first, second, or third, would it be any more awesome for you? No, so it's a combination. If you gave those people jobs, all 3 of them got to do something different, or they got to sit even in different spots on the bus, then would order matter? Yes. So then it would be a permutation. Okay? Now, permutations, remember I told you that the n has to be at least equal to or greater than the r, right? So if you have 6, you could do 6p6, you could do 6p5, you could do 6p4, but this number has to be bigger or equal to the r. We agree? It's the same thing with combinations. Combinations are a little more fancy though. So here it says, so we do our normal math, we go to probability, and instead of picking 2, we'd pick 3. It's the C, right? Now, punch 10C6 into your calculator and tell me what the answer is. So we have 10 people, let's say, and we choose 6 to go on a trip, correct? What's your answer? 210. Now, 10C6 is going to be smaller than 10P6, is it not? Because 10P6 order matters. So then if you picked 6 people to go on a trip, didn't matter what order they are, that would all count as one way, right? If it was a combination. But if it was a permutation, the 6 people you picked, you could then rearrange them in a whole bunch of different orders and it would change it, right? So you'd have way more differences of picking those 6 people if it was a permutation. Yeah? Put 10C4 into your calculator. What does 10C4 equal? 210. Now, why the heck is that even the case? It's only the case because of the formula. This doesn't work with permutations. It only works with combinations because the combination formula has that separate little r factorial in the denominator, doesn't it? Permutation one had n factorial over n minus r. The combination one has n factorial over n minus r factorial, correct? So let's fill it in for 10C6 and fill it in for 10C4 and see why they're the same. So if I do 10C6, I'm going to get, this is my n, this is my r, so wherever I have an n or wherever I have an r, I fill them in. So I'm going to have 10 factorial over 10 minus 6 factorial, 6 factorial. And the answer to that is 10 factorial over 4 factorial, 6 factorial. We agree? Without punching it into our calculator, that would be the end result. 10 factorial over 4 factorial times 6 factorial. And if we punch it into our calculator, we make sure to have our denominator in brackets because we have 2 things multiplied together. If not, it will do order of operations and give us the wrong answer. Okay, let's try 10C4. So it's going to be 10 factorial over 10 minus 4 factorial, 4 factorial, which is 10 factorial. Oh, it just disconnected somehow. Matter. Equals 10 factorial over 6 factorial, 4 factorial. Are they the same? If you have 6 times 6 factorial times 4 factorial on the denominator, or 4 factorial times 6 factorial, is it any different? Is 6 times 4 any different than 4 times 6? No, putting a factorial on it isn't going to change the game. So that's the reason why. Because if you look at these, they actually have a common difference. This one is a difference of 4. So that's why I do 10C4. So if I gave you 100C90, that would be equal to 100C what? 10. And it only works because you have that r factorial in the denominator. That's why for p's, if it's 10p6, it's 10p6. You can't change it. Okay? So this would be 100c10. So what they could do is, okay, I have 100 kids in the school and I pick 10 to go on the trip, right? They just get to go on the trip or not. So you'd say 10c or 100c10, would you not? But on the multiple choice answers on the diploma, they have 100c90. Are they wrong? No, because that's the same thing. Okay? So you have to keep in mind that even though 100c10 is correct, 100c90 is the same answer. So they'll keep it. Okay? And how do they do it so that you can't just test them out by like guess and check? They'll use variables. So they could go 100 CA would be equal to 100 C what? 100 minus A. Right? They're the same things. So that's the formula. All right? Make sense? Okay. Example 1. 3 students from a class of 10 are chosen to go on a school trip. In how many ways can they be selected? Is there anything special about the school trip? Are those 3 students any more special if you're picked first, second, or third? No, you get to go or you don't. So it's just going to be 10 C, how many? 3. Or 10 C, 7. Or 10 3. Or 10 7. All the same thing, right? What's the answer to that? How many different ways can you pick 3 from 10 if order doesn't matter? That's what we're asking. What's 10C3? Yeah? Can you do it? Anyone? 120? Do 10P3. $720. Way more, correct? Because you're taking those 3 people that you picked, and now you're rearranging them because the order matters. What do you think they're going to have on the diploma for answers? 10C3 and 10P3. So if you don't know, you're 50-50 guessing. They're not going to just not put the P ones on when it's a C. Okay, they're never going to do that. So you need to know the difference because they're going to have the answer to both. Or it's a numeric response and you have no answers, and so you're really just doing your answers. Okay, Lotto 649. It's called Lotto 649 because you pick 6 numbers out of 49. That's why it's called Lotto 649. Interesting. Okay, now, Lotto 649, you pick 6 numbers, and then on the little ticket, it gives you the 6 numbers in order from lowest to highest. Okay? It's hard enough to win it, being that it's a combination. So when they draw the 6 numbers, you don't have to have them in that exact order that they're drawn, correct? Like if out pops a 3, you don't have to have a 3 first on your ticket. You will, because it's going to start from lowest to highest. But anyways, when it pops out a 3, if you have a 1, 2, and then a 3, say, you pick those numbers, you have a 3, they match, yay. And then out pops a 1, good. Like they don't have to be in the same order that they pop out of the machine. I don't know how they do it now. They used to do it as like little bingo balls, but they don't do that anymore. I'm pretty sure it's a computer. But the 6 numbers don't have to be in order. Okay? So we're choosing 6. So Jasper selected the 6 numbers from the birth dates of his family. 3, 7, 9, 11, 20, 29. How many different selections of numbers could he have made? Does the order in which those come out matter? No. So it's what? Permutation or combination? Combination, because those 6, the order doesn't matter, right? They come out. If you have it, yay. If you don't, ugh. So it's going to be 49, choose 6. So do that into your calculator. Go 49C6. It's ginormous, just so you know. What is it? So you have a 1 in 13,983,860 chance of winning the lotto. Yeah? Now, what if the order of which you pick the numbers mattered? Do 49p6. It would be 1006. 1, 2, 3, 4, 5, 6, 7, 8, 9. It'd be 100683475520. One in that chance. You're never winning. Like, it's not happening. Okay? So people think, oh, 4926, I can win 13 million, almost 14 million, right? Plus, is every single choice chosen? Probably not every single time. That's why the lottery sometimes moves on to the next week, because someone actually didn't pick the 6 numbers, right? Because 10 people can pick the same numbers, and then one set of 6 numbers never gets picked. Okay. All right? Okay. The athletic council decides to form a subcommittee of 7 council members. So they have a committee, this athletic committee, that has X number of people. I don't know because I haven't kept reading. In that committee, they want to form a small subcommittee, right? To look at how funds raised should be spent on sports activities in school. There are 15 athletic council members. There's 15 total. They want a subcommittee of 7 of those, so like a little less than half. 9 males and 6 females. If I just asked you how many councils could you make? How many different subcommittees could you make? And I didn't say boys or girls. What would you do? 15, C. How many are we choosing? 7, right? So if I didn't specify boys and girls, I would just take all the council members and I choose 7 of them. We agree? But it actually says the subcommittee must consist of exactly 3 females. The moment they say exactly 3 females, it scares me because they don't actually tell you how many males, and then some people only find females. We need a subcommittee of how many people? 7. We have exactly 3 females, so we need, and what? How many males? 4 males. Grade 1 subtraction coming back at you. So we needed 7, we take off 3, we need 4 more, right? Yes, grade 1, yay. And you thought it was hard back then, I'm sure. Okay, because you couldn't play anymore like kindergarten. Okay. How can we guarantee choosing females? How can we guarantee from those 15 people that we are choosing from, like, females? Guaranteed getting 3 females. Yeah. Yes. We have to actually choose them from the females, right? You take all 6 females, you choose 3. You take all 9 males and you choose 4. That's the only way you can guarantee getting a male, choosing a male from a male, female from a female. If you were choosing principals and teachers to form a new school from all the principals and all the teachers in the school division, you choose principals from principals and teachers from teachers. Some teachers can become principals, yeah, blah, blah, blah. Nonetheless, principals from principals, teachers from teachers, if you're just moving them and you weren't letting them choose. Okay? So, the 7 council members still doesn't matter because they don't have any special jobs as the subcommittee, right? They just get to be on the subcommittee or they're not. So it's a C, we know that. So we're going to do 6C3, 9C4. We have to decide, do we add or subtract them? Do we want 3 females or 4 males to form the subcommittee? Or do we want 3 females and 4 males to form the subcommittee? And or multiply. Because we want and, right? So if we say and, we multiply. If we say or, we add. So we want the 3 oh, wow, this is really hard. 3 females and 4 males. So we multiply. Okay? What's 6C3 times 9C4? And you can put it all in at once in your calculator. It will actually do them. You don't need brackets around it. You can just go 6C3 times 9C4. What'd you guys get? 2,500 and sorry? 20? Okay. The next one says, in how many ways can the subcommittee be selected if Bruce, the football coach, must be included? The only catch on combinations when you actually have a restriction is it just makes you be able to choose less after you deal with the restriction. Okay? Now, on the diploma, they would probably have to say, in how many ways can the subcommittee be selected if Bruce, the male football coach, must be included? Because some people might be like, well, Bruce is a female. They would fight me. So they'd have to say Bruce, the male football coach, must be included. Okay? So we want to get Bruce. So the only way we can guarantee getting, and we know the subcommittee has no jobs, nothing special. So it's going to be C no matter what, correct? Doesn't matter if I ask for females, a coach, whatever, it's going to be C's. Okay? The only way I could guarantee getting females was choosing them from females. The only way I could guarantee getting males was choosing them from males. Yes? Principals from principals, teachers from teachers. So what's the only way I can guarantee getting Bruce? Choosing from Bruce. Okay. So we want Bruce. We're going to do one, choose one. Now we have Bruce. Okay? It didn't change. We still need 3 females. Is Bruce a female? No. So did he knock down the females at all? No. So it's still going to be 6, choose 3. However, what's the males going to be? It's going to be 8. So everyone remembers to knock the choose 3 down, but they forget to knock the total that you're choosing from down because we took a boy out. So instead of having 9 males now, Bruce is out. He's out of the 4 that I need, and he's out of the 9 males, right? So it's 8, choose 3. Everyone's really good at remembering to knock this down to 3. Everyone's really bad at forgetting to knock that down. Okay? If you're that person who said 9, this is how you do your notes. You go there and you star it so that when you go back to your notes, you actually remember what the heck you were doing because later on you're not going to remember. And you're going to say, don't forget to decrease the males by 1 and the choice of males by 1. In your notes, if you're someone who would have done that, you leave yourself a star so that when you go back, you remember it because you were one of those people who would have done it that way. Okay? So 1, choose 1 is one way. I just took Bruce from Bruce. One way. 1 times 6, choose 3 times 8, choose 3. What do you get? Okay. Cards. So on your test, if I give you a card question, I'll give you an array of the cards in color. Okay? Because I didn't realize how many people have never played cards. Okay. And on the diploma, they don't assume that you actually know a deck of cards. So they would have to give you an array as well of all the cards. So like ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen, in hearts, in red. Then they'd have to do the same thing, clubs in black. Same thing, diamonds in red. Same thing, spades in black. Okay? And they'd have to show you all the cards. More often what they do than doing that is they make up a whole new deck of cards for everyone. There's a deck of cards, numbers 1 to 4 in blue, green, purple, and orange. Like, they totally make it so that it's completely, no one has ever heard of these deck of cards. They are strange, okay? So it's fair game. No one has a clue of these cards before you walk into that test. So, just so you do know, because I don't have an array, there are 4 suits: spades, clubs, diamonds, hearts. Diamonds and hearts are in red. Spades and clubs are in black. They do it here, but I'm just going to do colors just here. There are 13 cards in every suit. 13 times 4 is 52 cards total. The face cards are the ones with faces on them, which are jacks, queens, and kings. They're the royalty ones. Okay? So if there's 3, a jack, a king, and a queen in each suit, and there's 4 suits, there's actually 12 face cards total, right? If half the deck is red, there are 26 red, because you do 52 divided by 2. And there's 26 black. And then there's 13 in each of these suits. 13 times 4, 52. Okay? Very big rundown of cards in a very short period of time. Now, we can't assume that in most games you have a 5-card hand, but you might be crazy eights and have an 8-card hand, or, you know. So there's no such thing that every single card game has 5 cards. So you have to read, because they'll tell you how many cards it needs to have. So this one says, how many different 5-card poker hands are possible? Now, 99.9% of the time, and I'd say 100%, but someone could make a wonky question on a diploma and prove me wrong. Cards are combinations. Because when you get a card hand, and if you've ever played cards before, you can go fish or old maid, that one especially, because you can move cards around all you want. Once you get the cards in your hand, do you have to keep them in the order that the dealer dealt them to you? Like they deal one to you and you have to keep them like this? No, it depends on what game you're in. Some games suits are what you want, so you put all the different suits together. Sometimes it's the old maid and you think someone's going to grab an edge card, so you stick the old maid in the side or on this side or in the middle, right? So cards, does the order matter in which you're dealt them? Do you have to keep them in that order and then play them in that order with cards? No, cards order doesn't matter. You get them in your hand, you move them around, you can play whatever ones you want. So it doesn't matter if you get them in this order. Immediately once they're in my hand, I start moving my cards, right? So order doesn't matter. So cards are combinations. However, they could make up a random game somehow that the way you're dealt the cards, you have to keep them and then lay them down in that order. Then it would be a permutation. I've never seen it, but I'm just explaining to you that they could possibly do it, right? So unless they say the cards that you are dealt have to be played in that exact order, it's a combination, okay? So 99.99999% of the time, cards are combinations. But there is that chance that they give you the cards, you have to play them in that order, then permutation, okay? So we have a 5-card hand. Does it have to be specifically kings or queens or aces or twos or reds or blacks or anything specific about it? No, I just need 5 cards. How many total do I have? 52. So I do 52C5. And I don't even care if you give me a total because honestly, you can all punch in your calculator. That shouldn't be your, if that is your problem, get help, okay? We don't want you not being able to get it because you can't type it in. All right, now, in how many hands will there be? So we still have 5-card hands here. It hasn't changed, but now we're asking for specific types of hands, okay? All diamonds. So if we want all diamonds, that means we can only choose from 13, the diamonds, right? The only way you can guarantee getting diamonds is diamonds, kings from kings, queens from queens, twos from twos, red from red, black from black, right? So this one, you're right, it's going to be 13, and we're going to choose 5. In every single one of these different examples, I'm starting over with trying to get a 5-card hand, correct? Every single time. So the next one, I want 4 black cards and 1 red card. Card, not a car. That's weird. Okay, and means multiply. And I need an and because I need 5 cards. If I put an or, I have one option of 4 cards and then another card hand with 1 card. Like that's not good. So or doesn't make sense. So I want black cards. How many black cards are there to choose from? 26, half the deck. So I do 26, choose 4. How many red cards? 26. Choose 1. Okay. 3 kings and 2 queens. The only way we can guarantee getting kings is choosing from kings. There's a king in every suit, right? So how many kings are there? There's 1 heart king, 1 diamond king, 1 spade king, 1 club king. There are 4. How many queens are there? 4. Okay. What's the problem with number 4? There are 2 cards missing here. We only have 3, right? So we know we want 3 kings. That means exactly 3 kings, correct? So could I get 4? Would that be okay? No, I want 3 kings. So when they don't give you this, you do 3 kings and 2 other cards other than king. Okay? So kings, there's 4, choose 3. Bless you. That'll be an answer on the diploma, 4, choose 3. Because they're going to think that you probably forgot to add the other 2 cards. Correct? Another answer they're going to give is 4, choose 3. 49, choose 2. And you might be like, well, why not? That's correct. It's not correct. 49, choose 2. You're telling me, yes, I used up 3 cards, so I still have 49 left. However, one of those 49s is a king, and I'm only allowed to have 3. So I can't just take off the 3 kings. I actually have to take off the 4 kings. Even though I didn't use all 4, that doesn't matter. I can have exactly 3. So you see how they're going to have that error? They're going to have 4 choose 3 times 49 choose 3, or choose 2. That would be really wrong. 49 choose 2, which is wrong. You need to take off all the kings because it's two other than kings. How many kings are there? 4. Take the 4 kings off. I have 48 cards left. 48 choose 2. Okay? Do you know what else errors they're probably going to give? What's a really easy way to make perms and coms answers? Same thing with a P. If you don't know if it's perm or a com, you're hooped, right? So if I was making this, I'd go 4C3 as one answer. I'd go 4P3 as one answer. I'd go 49. I have options. There's too many options. I have 5 options I could do. I could do 4C3, 49C2. I could go 4C3 or 4P3, 48P2. Oh, there's so many options. So that's what they're going to do. All of your common errors are the other 3 answers. That's why diploma questions are really hard. Not that other tests it wasn't like that, but they spend lots of time making sure that those are, and field testing them. And if one answer doesn't give you good enough statistics, then that answer, we have to try and fix it and make it a better one that someone will pick. So if one is like 3% only picking it, that's a really crappy answer. That's just someone just put something random. No one's picking it. Then they have to fix that. Okay. Also, if the top end, when they do field testing, if the top end is getting the answer wrong more than the bottom end, that means there's like a faulty part of the question that they're reading into and changing the answers. So the top end has to be the ones who are getting the most right. It's a whole big shabazzle. So the best thing to do, know your stuff. Get the correct answer. Move on. Don't care about whatever the crap they wrote on the sides of the B's, C's, and D's, right? Just get it right. Easy said, right? Yeah. Totally easy. No big deal. MBD. Okay. Moving on. At least at most. Okay. Last thing about combinations. At least at most. At least at most means you're going to have cases. Remember, the moment you have at least or at most, you have cases. Because at least 3 means you could have 3, or you could have 4, or you could have 5. And I always think of it as money. If I need at least $3, I need $3 or more. If I need at most $3, I need $3 or less. Okay? So we're going to look at this first one. 12 adults and 18 kids are on the prom program planning committee. That is a tongue twister. Prom program planning committee. A smaller group of them, 5 people only, those ones fighting for these positions, because it'd be super fun, needs to decide on the themes. How many different ways can this smaller group subcommittee consist of at least 4 adults? So you have to think, first, the subcommittee, does it have specific jobs? No, it doesn't have specific jobs, so it's a combination. It's also in this lesson, so it's a combination. But on the unit test, it won't be in this lesson, correct? Because there's no lessons. It's just sporadic. So you always think, I'm picking a subcommittee. Does it have jobs? Yes. Permutation. Does it not have jobs? No. Combination. Okay? So we know it's combination. We need at least 4 adults. Okay? We need at least 4 adults. So we're making subcommittees. The first committee is 4 adults. Is it 4 adults only? How many people do I need on a subcommittee? 5. So each different, what are they called? Plus signs in between. Case. Wow, that was hard. Each different case has to have 5 people in it, right? Because each subcommittee needs to have 5. That's great. We have 4 adults, but I also need 5 people. So what do I need? And 1 kid. Is that all the subcommittees I can make with at least 4 adults? No, I can make 1 more subcommittee. How many would it have? 5 adults. So or, in between cases, you always have or, right? 5 adults and 0 kids. Do I have to have the 0 kids? No. This one is tricky if they'll only let you pick from 4 adults. So then people will go 5 adults And then they're like, 4, choose 5. And then they call me over and they're like, my calculator sucks. It doesn't work. No, it doesn't suck. 4, choose 5 doesn't happen. You can't have 4 adults and choose 5. Okay? Yes, there can be 5 adults. That's great. But if you only had 4 to choose from in the first place, this case is going to cause you issues. Correct? Is it going to cause us issues in this particular example? Is there at least 5 adults that we're getting to choose from? Yeah, we have 12 adults. So we could actually go up till 12. Would we keep going after 5? Some people are like 5, then 6, then 7, all the way to 12. No, our subcommittee can only have 5, so we're stopped here, 2 cases. Okay? Now, once again, if we want an adult, we have to choose from an adult. If we want a kid, we have to choose from a kid. So, we have 12, choose 4, times 18, choose 1, plus 12, choose 5. Why do I get 12 adults again? I already picked 4. Why isn't it 8? It's a new case, and when you have a new case, what happens? You get anything's possible. All dreams come true. When you get a new case, you get all your people back, right? Start over. What is this? If you want to do it in your calculator, you could do this. How many committees? Everyone should be typing it into their calculators. Put your hand if you have an answer. Look at someone beside you to make sure you have the same answer. You don't feel like you're going to be embarrassed. Yeah. Okay. Now at least one adult. So we're going to start with one adult. And 4 kids. Or 2 adults and 3 kids. Or 3 adults and 2 kids. Or 4 adults and 1 kid. Or yeah. So we can go 12C1 times 18C4 plus 12C2 times 18C3 plus 12C3 times 18C2 plus 9,702. Because I'm stealing that. And we get an answer, right? Like I said, the calculator doesn't seem to be the issue. It's often just setting it up, right? Okay, we have at most 2 adults. There is an error that happens with the at most all the time. Let's see if you do it or if you escape it. At most 2 adults. At most $2. Is $2 or less? At most 2 adults. Is 2 adults or less? So we're going to do 2 adults and 3 kids, or 1 adult and 4 kids. Yes, and 0 adults. Everyone forgets about the 0 case. We don't even need any adults. They don't need to pick out themes. It's not their prom. Get out of our faces. That's what you're thinking. 0 adults and 5 kids. Do I have to list the 0 adults? No. So we can do 12C2 times 18C3 plus 12C1 times 18C4 plus 18C5. Right? I want everyone to at least plug one of these in. So plug this one in. Everyone plug it in. I want to make sure you actually can get the answer, not that you get it wrong because you don't know how to use your calculator. Anyone? 59,808. We agree? Nada? What? Oh, look at that. 18. I bet you will have it in 3 shakes of a lamb's tail. Just 1 second. 3 shakes. Lambs. Oh, this was a little downhill. This is a C. No, you just missed it. You didn't. Is it 99,144? Yep. Oh. I don't remember what I said. Awesome. All of it. Practice makes perfect. As my daughter says, practice makes progress. Because it sometimes doesn't make perfect.